But you can complete your final without a calculator for the first semester. Actually, for both semesters. Yeah. It'll be in the review. If you hit the Chapter 1 tab in the middle content area, it'll be up in there. All right. So let's talk about our section 1.6 is coordinate geometry. It's basically the algebra that was created based on geometry. And so most of what I'm talking about, this should all be review for you. In some of the problems that you're going to see later, there will be some more challenging problems than you would expect. But for here, the real straightforward ones, this should all be review. Right? In looking at coordinate geometry, there's several different names that it goes by. Okay, so coordinate geometry goes by analytic geometry. It goes by Cartesian geometry, and it's basically just the way that geometry transformed into what we call algebra now. Right, and so in looking at this, we are going to be dealing with the coordinate plane. The coordinate plane, if you recall, has a horizontal axis called the x-axis. Has a vertical axis called the y-axis. The intersection of those is called the origin. Okay, and you can see here any points that fall to the right of the origin have a positive x coordinate. Any points that fall to the left have a negative x coordinate. Any points that fall above the origin have a positive y. Any points that fall below it have a negative y. And when we talk about the coordinates, we're talking about an ordered pair. And the ordered pair is just some set of coordinates x, y that allow you to specify a location for any geometric elements. And so before this Cartesian geometry came along, anytime that you would work with an angle or a point or a segment, it didn't matter how it was oriented. It didn't matter where it was located. And so algebra was created to specify when there are different segments, even if they're equal in all the other respects. Okay, so when you're looking at this, the two axes that intersect split a coordinate plane into 4 quadrants. They start in the upper right and move counterclockwise. So here's quadrant 1, 2, 3, and 4. Okay, and there's some general tendencies as far as the coordinates go for these ordered pair. If you have a set of coordinates in the first quadrant, its x-coordinate will be positive, its y-coordinate will be positive. What if you have a point in quadrant 2? The x-coordinate is negative and the y-coordinate is positive. In quadrant 3, the x-coordinate is and the y is. So they're both negative. And then finally in quadrant 4, the x is and the y is negative. Okay, so again, it's pretty consistent. There's not a whole lot to that. Right, so you do need to be able to identify where points are located, or in which quadrant they're located. You also need to be able to locate or plot the points. Okay, so I want you just to take a second, or actually we'll look at this here real quickly. Okay, but if I plot, let's say the point 2, 7 and the point -3, -5. Okay, just talking through this, it should be review again, but if you plot the points, you just count through. So the x-coordinate, the ordered pair has an x-coordinate of 2, so we move 2 to the right, 1, 2. We move up 7, 1, 2, 3, 4, 5, 6, 7, and that becomes the point. We can label it by its coordinates. Okay, same with the -3, -5. We move -3, so 3 to the left on the x-axis, and then down 5, 1, 2, 3, 4, 5 on the y-axis. And if we label our point, we have our ordered pair.